In this video, let's see the topic on capacity from in-situ test by SPT, DCPT and pile load test. First of all, myself B. Chelapriya, Assistant Professor Civil, Rohini College of Engineering and Technology, Palkulam. So, capacity of in-situ test. There are three tests were conducted: standard penetration test, cone penetration test and pile load test. The SPT and CPT are already discussed in previous video. So, in standard penetration test, the load carrying capacity of your pile can be estimated from the SPT value, that is penetration value. So, for drive and pile, QP is 40 N dB by B in kilonewton per meter square, where QP is a point resistance and D is a length of the pile and B is a width of the pile. Next, QP, the value of QP is limited to 400 kilonewton. For high displacement pile, Fs value is 2 N bar kilonewton per meter square. For low displacement pile, Fs value is 1 N bar kilonewton per meter square, where N bar is an average uncorrected value. Next, for bored pile. So, for bored pile in sand, QP equal to 14 Newton dB by B kilonewton per meter square. Here dB is the actual penetration into a granular soil. If the bore pile in sand, Fs value is 0.67 N bar kilonewton per meter square. Next one is Dashcon test. In Dashcon test, for the point resistance, QP value is QC divided by 10 into dB by B in kilonewton per meter square. The unit skin friction, that is for dense sand, Fs value is QC divided by 200. For loose sand, Fs equal to QC divided by 400. For silt sand, Fs value is QC divided by 150. And next one is pile load test. The pile load test is the most reliable method for determining the load carrying capacity of a pile. Here, the loads are acting on the pile. The settlements are to be recorded from the dial gauges. So, while conducting a test, there may be exits of a load. So, the following are the loads which are be taken into the account while driving a pile or designing a pile. So, first one, direct vertical load coming from the superstructure. Next one, impact stress developed during the process of pile driving. Stress developed during handling operations. Bending stress developed due to a curvature of a pile or eccentricity of load coming on the pile. Next, lateral forces on wind, waves, current of water, etc. Next, impact force due to ice sheet. Next, force due to uplift pressure, earthquake forces, etc. This is a figure. So, in this figure, you can able to see the pile are inserted in a borehole. Above that, the loading platforms are to be made, which is to be supported with a 2 anchor, and the dial gauges are attached in a pile for determining the settlement. Here, the loading can be done either by a two method, gravity method or truss method. So, this is for reaction truss method. So, following the procedure. So, first set up the for the load test on a pile consisting of two anchoring pile. Above that, loading platform are to be made. Here, first the test pit should be at least 3B or 2.5 meter clear from the anchor pile, and the load is applied by hydraulic jack. Next, the settlements are to be recorded with a 3 dial gauges, which is fixed with a reference mark. Next, the test is conducted for a period of time, that is 3 days for installation for a test pile in sandy soil, after 1 month for a silt or soft clay. Because during driving the test of pile, the soil properties are altered. With a passage of time, they may be recovered or restored. Next, load is generally applied, that is 1/5 of the allowable load, and settlements are recorded in the 3 dial gauges. Each load increment should be kept for a sufficient time when the settlement is become less than 0.02 mm per hour. Next, load is maintained till the rate of movement of piles are not more than 0.1 mm per hour in sandy soil, and 0.02 mm per hour in clay layered soils. Next, for each load increment, the settlement are observed in corresponding time, that is 0.5, 1, 2, 4, 8, 12, 16, 20, 60 minutes. Next, the test pile is loaded until the ultimate load is reached. Next, the load is increased to a value of 2.5 times of an allowable load, and it is removed as a same decrement through a same interval. After 24 hours, the entire load has been removed. The measured value of settlements are plotted against the corresponding value of load. So the load settlement curves are obtained. The below figure shows the load settlement curve as well as unloading obtained from the pile load test. So this is a load settlement curve. The graph is plotted between the load and the settlement. So the ultimate load is clearly indicated from the load settlement curve by approaching a vertical point. Next, the ultimate load cannot be obtained from the settlement curve. The allowable load is taken as follow. So sometimes the allowable load can be clearly indicated by drawing a graph. Sometimes it may not be obtained. So in that times, the allowable load is taken as a 1/2 to 1/3 of your final load, which causes a settlement up to a 10% of pile diameter, or 2/3 of your pile load, which causes a settlement for 12 mm, and 2/3 of final load, which causes a net settlement of about 6 mm. For a given load, the net settlement value is given by Sn equal to St minus Se, where Sn is a net settlement, St is a total settlement, and Se is an elastic settlement. And below figure shows a two load settlement curve obtained from a pile load test on two different soils. So here the ultimate load is found out by the intersection of initial and the final tangent line. So the allowable load is usually taken as 1/2 of the ultimate load. So in figure you can see that the initial and final loads draw a tangent line and take the ultimate load. Next, causes of failure of piles. What are the causes of failure of pile? The most common are statistical, the absence of the absence of statistical data regarding to a number of soil strata where the piles have to be driven, and bad workmanship and breakage due to in case of timber pile, if use of timber pile, bulking of pile due to the removal of side support, and the actual load coming from the pile is more than the design load, or any lateral forces, or due to improper choice of type of pile, or improper classification, or improper method used for driving a pile, or pressure of soft strata just below the tip of the pile, or wrong use of pile formula for determining the load carrying capacity, or lateral forces such as wind, waves, current, etc. So while selecting a pile, the following factors are to be considered. First one is type, size and weight of the structure to be supported. Next one is physical property of soil stratum, or depth of stratum capable for supporting the pile, availability of materials for a pile. Next, what are the driving equipment used for it, and durability required, and comparative in place of cost, and type of structure adjacent to a project, and type and kind of water table level. So these are the factors to be considered while selection of a pile. So in this video we learn about the capacity in situ test, that is standard penetration, cone test and pile load test. Thank you.